Okay, Assalamualaikum and a very good afternoon, everyone, or good evening. All right, so now I would like to discuss our last quiz, which is actually it is a combination of two part of or two chapters. So I name it quiz 3 and quiz 4. So the marks will be all 10 marks will be counted. So you will get 5 for each in total. All right. So the previous one that I give as individual assignment is maintained as individual assignment, right? So the question one, the wrong method for analysis instrument faulty and contaminated chemical reagent are considered as I told you in the class, gross error. Okay, this is major error. We need to repeat the experiment. Right, and then question number two, which one, sorry, this is a typing error as I told during the quiz. Which one, okay, is the example of one-tailed F-test? Of course, a proposed method compared with standardized method. If the question asks you about this one is a proposed method and compare, this is a set data of a set of data of a proposed method and compare with a standardized method. So you guys need to use one-tailed F-test, all right? To compare, is it okay with the proposed method or not comparable with the standardized method? Okay. And then question number three is an analysis of cadmium content in standard reference material. This is a standard. We know the concentration. And then the reason that we use standard reference material is to test our method or our instrument. Okay, we know the exact concentration in the material okay, we know exact concentration of the cadmium, for example, in the material, the standard reference material. And we want to test either our method and also our instrument is okay or not, can detect the exact value or not. So the exact value is 3.5 ppm or 3.5 milligram per liter. However, for replicates of the result were 4.2, 4.1, 4.1, and 4.15 ppm or milligram per liter. So it is not considered as close to the true value, which is the true value is 3.5 ppm. The result is consistent at another value. So the result can be considered as accurate rather than precise. Is it accurate? No, it's not accurate. It is precise because the result is maintained at a certain value, but it is not accurate to the true value. So true or false? It is false. This is not accurate. It is precise. Question number 4, external calibration was done by preparing a set of 5 standard concentration and plotting the linear graph to get R square value. True or false? Of course, if calibration, we prepare a calibration solution with a standard concentration, okay, not we add into a sample inside, okay, it is the external calibration. So it is true. And then question number 5, listed below are method performance parameters except, okay, sensitivity is true, limit of detection is true, limit of precision, no, we don't have limit of precision in statistic. It is just made up, okay? So if you saw this, it is not one of the parameters. And reproducibility also considered as the method performance parameter. So the answer is C, okay? Limit of precision, no, it is not the method performance parameters. So question number 6, aluminum hydroxide, AlOH3, all right, will begin to precipitate at pH 7.39 from 0.2 molar aluminum chloride. Given Ksp is 2 times 10 to the power of negative 23. True or false? So this is false. If you calculate the S value, okay, and then you will get, okay, the S value is how much, and then the S value is considered as the concentration of OH, and then the concentration of OH, so we negative log, so we get the POH. So the POH, if we calculate, we get 7.39. So for pH, we must deduct 14 minus 7.39. So you got the pH 6 point something. So it is false. It is not, the value is not pH, it is POH. So you need to 14 minus this value. So we'll get the true pH. All right, so this is false. Number 7, image 1 above describe the type of impurities which is known as occlusion. All right, this is occlusion because during the rate of growth particle, the rate of nucleation and particle growth is so fast, so that an impurity is trapped inside the structure of the precipitate. So it is called as occlusion. Okay, occlusion, not surface adsorption. If surface adsorption, something absorbed on the surface, right? Not interstitial, not a substitution. So number 8, below are requirement for precipitate in gravimetric analysis, except, of course, we don't need the requirement of reactive with water. If it is reactive with water, so we cannot filter it. We cannot wash it, sorry. We cannot wash it with water. So the precipitate that we must get is not reactive with water, so that easily for us to wash. Number 9, given the AGCL, KSP, AGBR, KSP, and AGI, KSP, all right, based on all this value, is it true or false that silver chloride is the most soluble in water, right? What is the what is that I told in the class? Okay, so silver chloride, what is the value of KSP of silver chloride? It is the highest, okay, among the others. So it is most soluble in water because the lower the KSP, right? What is the the lower the KSP, it is more soluble. All right. Sorry. Wait for a while. AGCL, we are given AGCL, AGBR, and AGI KSP there, right? And based on the KSP value above, silver chloride, which is the first one, okay, is the most soluble in water. True or false? Of course, it is true because AGCL, all right, has the highest value of KSP, because the formula is the less the value of KSP, the less soluble the compound. Okay, because what? Because what is the value of KSP? We need to times the concentration of both ion. Okay, for example, AgCl, we time the concentration Ag and Cl, so we get the Q value, and at the Q value at the Q value, precipitate start to grow is KSP. So at the KSP value, okay, it is at the equilibrium. It is start to precipitate. So the lower the value of KSP, so the easier, the lower the value of the KSP, the easier the compound to be precipitate. Okay, meaning that Q is achieving KSP at a lower concentration. So given that the KSP for silver chloride is 1.6 times 10 to power of -10. All right, so this is a large value of KSP compared to others. Okay, so it is more soluble in water. All right, because it is the KSP is quite high compared to others, so it is hard for the compound to precipitate to achieve Q equal to KSP. All right, and then number 10, dimethyl glyoxime is an organic, or DMG, is an organic precipitant which can precipitate nickel, platinum, and palladium. How we can enhance the selectivity of this organic precipitate? So by controlling the pH and concentration of the masking agents, right? Not reaction time, not reaction volume, not reaction molar solubility. It is by controlling the pH and controlling them of the masking agents. All right. So that's all for the quiz 3 and 4 discussion. So given together with this discussion is your carry mark, all right, of all the assessment that have been done. So congratulations, and till we meet again during the final exam. Bye bye. Assalamualaikum.